All right, welcome back again. We are starting chapter 12 in business math this week. So chapter 12, section 1 is certificates of deposits, otherwise called CDs. We tend not to say the full certificate of deposit, but they will kind of interchange that here on this worksheet. As always, make sure you have your textbook. You've been reading through the sections. There is information in there that you need to complete some of these problems. So they always give you a little bit at the beginning here, just to kind of break it down, tell you what the section's about. So your money earns interest at a higher rate when you buy a certificate of deposit, or CD, than it does when you invest it in a regular savings account. Most CDs earn interest compounded daily, monthly, or quarterly. The word compounded just means that's how many times it's added back into your account, and it can actually start earning interest. So it's earning interest on itself. Kind of an interesting concept there. So if it's compounded daily, it means every single day it earns interest, and then it's added into the account, and tomorrow that interest is going to start earning interest with the rest of your money. So it becomes your money and it earns interest. And then it's going to be added at the end of the day, and the same thing. So it cycles every single day. If it's monthly, then you earn interest all month long, and then it gets added to the account. That's pretty normal for most like savings accounts. And then once it's added to the account, it starts to earn its own interest also, just like the daily, just not quite as often. Quarterly, that means just like quarters in a dollar, 4 quarters. Doesn't quite mean the same thing when we're talking about a year, but it's every 3 months it's added. So there's 4 quarters in a year. So you'd earn interest for 3 full months, then it would be added, and then it would start to add or calculate interest on that. So if it's not compounded yet, it doesn't earn its own interest. Once it's compounded, meaning added back to your account, it starts to earn the interest. So kind of a long definition for that word, but that's what compounded means. Then we come down to these 2 formulas here. So we have amount, and it equals the original principal, so what you put in, times the amount of dollar. And it's kind of a weird way to say that. It has to do this table down here. So amount of $1 invested, daily, monthly, and quarterly compounding. So if we look at this table, remember the tables, that's just informational. If there were something missing in here, you would not fill it in. You only fill the tables that are numbered like problems, 1, 2, 3, 4, like this one down here. But this one up here, this is an informational table. It's giving you the data you need in order to calculate these problems. So when it says amount of dollar, you need to find in this table where it is. And this one's a bit more complicated as far as tables go. So we have interest period 1 year. So are you choosing 1 year, or interest period 4 years? So it's going to tell you either 1 year or 4 years. You need to pay attention to that, because there's a line here that kind of divides this into almost 2 tables. We have the 1 year portion and we have the 4 year portion. And then we have daily, monthly, quarterly for each one. Again, daily, monthly, quarterly. So you need to know, is it 1 year daily? Is it 1 year monthly? Is it 1 year quarterly? Depends on which one you're going to choose. 4 year, is it 4 year daily, 4 year monthly, 4 year quarterly? And what the daily, monthly, quarterly mean, again, we're going back to that compounded amount. So this table gives you these amounts, what to multiply by. That's what this means, amount of dollar, or $1. So for every dollar you invest, this is what you're going to multiply by. This is how much interest you make. So that's what that means. All right, I'm going to erase all this junk that I have in here. So compound interest equals the amount minus the original amount. So that's just the interest, compound interest. There's a compound interest formula. We'll come to that in just a few minutes here, or more toward the end of the video. But compound interest, it's just simply saying how much did you put in, the original amount, or how much do you have right now in your account, minus the original amount you put in. So that's how you know how much interest you've made. All right, so let's go ahead and take a look at this first one. I'm not going to fill out this whole table for you. We're only going to do number 1, and then I'm going to let you fill out the rest. So the main thing you want to pay attention to here is what the columns are giving you. They're giving you a lot of information very quickly. So annual rate, it's telling you the rate. If you notice, there is a column for annual rate that matters. That's going to change this number that you're grabbing. Okay. And then interest period. So it's telling me 1 year, quarterly. I need to make sure I'm paying attention to both of those. So I have 1 year, I have quarterly, and then 3% is this first one here, 3%. So, using this, don't mark up your graph so much because then, it's going to be hard to read when you need to go through here. But I'm just showing you, I'm going all the way over here to the quarterly column here that I circled. So I'm going to use that number there. So I'm going to erase all this stuff just so that it's not in my way. So I'm going to write this number right here, down here, 1.0303339. Don't shorten it. Don't round it. You need to leave it the whole number or you're going to lose some money, honestly. You don't want to lose any money. You need the whole decimal here, okay? So don't round anything. Leave the whole thing there. And so all you're doing on this whole row is that same thing. You're going to match up the percentage to which chart is it coming from. So we have 4 years daily, 4 years monthly, 1 year quarterly, 1 year monthly, 4 years quarterly. So I'm underlining those separately because they matter. We have to pay attention to those. So 4 years, I'll go ahead and do the second one. So we have one year and 1 4 year. I'll change my mind on not doing more than one. So 4 years daily. So I had the 1 year. I'm going to go over here to the 4 years and daily. And then I have 3.5% now. So I have to go down here to 3.5%. And I'm going to come over here in the chart to my daily and down here. So here's the amount where they cross. I'm kind of using that reference, almost like a multiplication chart there, back from elementary school there. So this is the amount we want to write in there. I'm going to erase all this stuff. So we're going to write 1.150266. Okay, so all we're doing, this is the amount per dollar, meaning this is how much I make for every dollar I put in that account. So now what we want to do is when they say amount, they want to know, how much are you going to have at the end of this period. And what they're doing, this amount, they're actually taking the compound interest formula that we'll talk about in just a little bit, and they're doing the main calculation for you. So they're actually bringing down a bunch of calculations and giving you the main number there. So you're only doing one calculation out of, I think, 3. Yeah, because you're going to divide, add, use an exponent, and then you multiply. So, sorry, we'll get there. That'll make a little more sense, I think, when I show you the formula. But we're doing one calculation here instead of the whole formula. That's where they're getting this number from. So when we do the amount, what we want to do is we want to multiply what we put in by this amount per dollar. And that'll tell us how much are we going to have at the end of this either 1 year or 4 year period. So when I multiply this first one here, I'm going to end up with $6,182.03. Sorry, squeaking over there into the next column. And this other one, so I'm just going to do both these at the same time, sorry. So $20,000, I'm multiplying by this number here. I'm going to have 23, here, let's erase that, it's ugly looking. $23,005.32. So at this point, you can definitely round if you have, more than 2 decimal places. We want to round on this one. A lot of the times banks round down, just so you know that. They don't tend to round up, not unless it's, pretty close up to the next number. But most of the time they're going to round down. And retail stores will round up when this happens. So they charge you more, but a lot of the time the bank will round down. It happens that way a lot. So they'll cheat you on that penny. Either way, as long as you're within a penny, you're fine. If you accidentally rounded up when you should have rounded down, it shouldn't be that big a deal on there. So interest earned, they simply want you to take the amount you have now. So that, like, this one is $6,182.03, and they want you to subtract what you put in there. So you put in $6,000. So what you have left is $182.03. That's your interest earned for this account. So you do the same thing for this next one. You have $23,005.32. You put in $20,000. You just subtract those two amounts. Tells you how much interest you earned. Okay, so you do the same thing for each one of these. Just keep in mind, pay attention to this chart. It has a lot of pieces there that you have to pay attention to. First, Is it 1 year or 4 year? Once you know that, then is it daily, monthly, or quarterly? And you have to do that for either one. So it doesn't matter which one you're looking at. You have to pay attention. Is it daily, monthly, or quarterly? And then once you know which column you're looking at, then look at the interest rate here and make sure you go across on that interest rate to kind of match, like I said, like a kind of a multiplication table type idea. Um, so that does have a lot of information kind of packed into a small chart. All right. The problem right down here below, let me move this up. You can see it. So this is exactly the same problem. You're using the exact same chart up here. So it's just giving it to you in slightly word problem form. So it's just letting you know, it's giving you a name now. It's a person, and they're investing $4,000. So we definitely still want to pay attention to how much they're investing. That's this column here, the original amount. 1 year CD. So they're still telling us the year. They separated, instead of saying 1 year monthly, they say 1 year CD at 4% compounded monthly. So it's here, it's just kind of separated in the sentence. So we know it's 1 year monthly, and then we know that it's a 4%. And remember, CD just means certificate of deposit. That's what we're talking about. But they're going to say it even on the next problem when we look at number 8. They say certificate of deposit instead of CD. So just make sure you understand that means the same thing. So you'll do the exact same idea. First, you need to make sure that you find this amount per dollar in the chart here. They gave you all the information. It's 1 year, monthly, and then you have your 4%. And you're going to multiply the amount you put in by that amount per dollar. That'll give you the first line. The second line is simply this last calculation we did in the chart here, where we subtract what do we have and what do we put in. Okay. All right, let's take a look at page 2. I need to move it up here. Oops, there we go. All right. So I believe, let me get over here. Page 2. So this one, exact same idea. Oops, I gotta get rid of that. So we have a 4-year certificate of deposit for $15,000. We know how much we're putting in. It's 4 years. The certificate earns 3.75% and it's compounded daily. We're given all the information we need. It's just a little bit more spread out now. So when you come to the word problem, you have to still pick out that important information. Really, do we need to know her name? No. Do we need all of this other information? Not necessarily, but it gives us a little more context. It makes it a little bit more real. It's a person now instead of just a chart of numbers. So you just pay attention to, your important information. You're going to go to the 4-year column, daily in the 4-year column, and then go down to where the 3.7 row is, 3.75 row is. And that's your amount per dollar. And she's putting $15,000 in. So we're going to multiply by 15,000. And that'll give us the amount we have right now at maturity. So after 4 years, that's how much we'll have. And then we simply subtract that amount from what we put in to get our interest earned. Okay, same thing. Haven't changed really anything there at all. The next couple are pretty much identical. The only difference with number 10, I'm going to point out, is it says or. So we're making a choice here. So the Nakatas have $30,000 they want to invest in a certificate of deposit. They can purchase a 4-year certificate from Citizens Bank that earns interest at a rate of 3.75 compounded quarterly, or a 4-year certificate from F&M Bank that earns interest at a rate of 3.75 compounded daily. So they have to make a choice. Which one is better? It's very similar. They're both 3.75. They're both 4-year, but one's compounded daily and one is compounded quarterly. That's going to make a difference. Because remember, compounded means how many times is the interest being added to the account so that it can actually make interest on itself. So if it's compounded daily, you're probably going to be making more money off of that one. They're not as common, honestly. I'll put that out there. It's not as common to find the interest compounded daily because you make more money off of that one. So you do the calculation for each one. Same calculation. You need to go to your chart, 4-year, and this one's going to be quarterly and the 3.75 column. And you calculate this out based on the 30,000. And then for the second one, for F&M Bank, same thing. You have your 4-year, but now you're going to go to the daily column and then still you're going to be in the same 3.75 row. And you're still using the 30,000 at the beginning of the calculation. That's the amount you're putting in. So the only thing that's changing the two calculations is the amount per dollar. How much am I making per dollar that I put into this account? And then they're asking you to subtract the difference in the maturity values of the two certificates. So just once you get your two amounts here, you subtract. What's the difference between the two? A little better question would probably be, which one should they choose? So which one would give you, more money, more interest back that you put in? But they're asking you for the difference there. So a little different on that one. Okay, so this one is definitely the most different, and sometimes these algebra ones can be a little bit difficult, these end algebra ones. So it even says algebra on it. Harry Miller deposits $20,000 in his Heritage Bank's 2.5 CD, so 2.5 year CD. So remember on that front page with this table, we had a 1 year period and a 4 year period. We don't have a 2.5 year period. So that table only has those numbers for either 1 year or 4 year. Once you start adding in different years like that, you're going to have to calculate that number that the table's giving you. So this one pays 5.25% compounded. I don't even think that's on the table here. It doesn't go that far, right? And we use the compound interest formula to determine the future value of Harry's $20,000 and how much interest Harry earned. So it tells us to use the compound interest formula. That is in your book. So if you haven't looked in your textbook yet, you need to look in your textbook. You should be reading every section before you do these worksheets. It will help you get through these worksheets easier if you read through and you look at the examples. So the compound interest formula, it's on page 442. And I'm going to write it out here. So we have A equals P times 1, 0, 0. So 1 plus R over N. All right. Let's see. Oh, I'm going to change this a little bit. So it should be R over N to the nth power, like that. So they kind of forgot that part on this worksheet here. So I do believe they give that to you in the textbook. Yes, they do. I can see it right there. So it should be good in the textbook. You want to make sure that you do this calculation, though, this R divided by N. So first, let's talk about what all this means. So A is your amount, meaning how much do I have at the end? That's the amount I'm going to end up with. P is your principal, which is the amount you're putting in. Okay, so how much did I actually put into the account? R is your rate, so what interest rate am I getting? And N, either one of these N's, is the number of periods. So usually number of, and I'm going to even change that, not periods, so it makes a little more sense, number of years. Because we always want to look at it in terms of years. So if it was only a month, you'd actually do 1 divided by 12, because it's 1 out of 12, that's the number of years it is. So you're never going to do 1 out of 12. I'm just saying you always want to look at it in terms of years. So to fill this in, we're going to have A equals our principal, which was the $20,000, times 1.0100. It's the 1. So remember how all the numbers, when we did the amount per dollar, it was always 1 point, a whole long number? This is where the 1 comes from. So it's 100% of your $20. You're going to get $20,000. You're going to get that back, plus whatever interest you're getting. So that's what this, on this chart, these 1 point something means. It means you're getting 100%. That's what the 1 stands for. So all of your money back, plus you're getting this piece back. Not a big piece, but you're going to get a piece of that $20,000 back. So that's what all these numbers mean. It's 100% and whatever interest rate you're getting. So what we're going to do here is plus our rate is this 5.25%. Make sure when you're doing percentages that, of course, you move the decimal. We don't ever want to type it in like this. We want to type it in like this. Oops, I forgot my decimal point. So it's 0.0525, not 5.25, because we want to do move the decimal to make it a percentage. Some of the calculators do have that little percentage symbol. Might be kind of hard to see it on here, but I can even show you my camera here. So might be a little difficult to make out there, but right there next to my division symbol, I have a percentage sign. So if I type in 5.25 and I hit that percentage sign, it'll move the decimal for me. Kind of crazy. It automatically does that. And a whole lot of calculators have that now. So we're going to divide this by the number of periods we have. Oop, and see, I did the wrong thing. Let's see. This is how compounded, number of times compounded is what this should be. Number of times compounded. Number of times, sorry, spelling things wrong, compounded. So, sorry, I gave you the wrong explanation on that one. I was looking at the formula too quickly. So this is the number of times compounded. So with this one, if it's quarterly, that's important. It means that it's compounded 4 times, added back to your count 4 times. So we're going to divide by 4 here. And then on the outside, we want n, and one thing I did forget on here, interesting, they forgot that on the formula, so I'm just realizing it now. There should be a t here, so n times t. And what t stands for, that's the number of years. So, sorry, a little convoluted there, didn't mean to be confusing. So we have a equals p times 1 plus r divided by n to the n times t power, to the power of n times t. So n is the number of times it's compounded per year, and t is the number of years that you're putting it in. So a little bit more there. Sorry, they left that part out, and I don't know if they put that part in the book. Interesting. I don't see that full calculation of the book. I see the kind of simpler one that I had in there, which is the r to the n power. So we definitely need a little bit more here to get the correct numbers. So we have our rate divided by our number of times compounded per year, 4 times. And then out here, we put 4 again because it's compounded 4 times. And we need to know total, how many times is it going to be compounded over the whole life of the CD. So that's why we do n times t out here. So it's 2.5, and this is a time symbol, not a decimal. All right, so if we simplify this, we have a equals 20,000 times 1.00 plus, we want to divide this. So if we divide this, we get 0.013125. That's 5.25% divided by 4. That's where I got that number. And then we're going to multiply these two together to simplify this a little more. So we have 4 times 2.5. Well, that gives us 10. So now, and here I'm going to scooch this up a little bit because I'm running out of room here. Boom. So now we have a equals 20,000 times, we're going to add these two together. So we're going to have 1.013125 to the 10th power. That's starting to look a lot more like those numbers in that chart, right? So it's starting to look like the number in the table. What we want to do now is raise it to the 10th power. So in order to do this, let me see, I'm going to grab my calculator so you can actually see. View, I want my scientific calculator. Okay, so this should look a lot like the calculators you have on your phone. If you have an Apple, if you have an Android still, they should look pretty similar to something along these lines. You can also download a scientific calculator if for some reason you don't have one. You can do this on a regular calculator too. Didn't want you to think you can't. So what we want to do is take this number, hope if I put it in there, 1.0 13125. And then you want to hit this button right here. So we want to hit this x to the y power. And then we need to tell it. So this is saying I'm not squaring it, I'm not cubing it. I have a bigger number than 2 or 3. I need a bigger number. So this one, I get to choose what y is. So after I touch this button, I need to type in that 10 because that's what I'm raising it to. That's my exponent here. So I'm going to hit equals. So this is now, uh-oh, I need my calculator back. I didn't have that number memorized, darn it. So I'm going to move this over here just so that it stops disappearing behind my sheet here, and I'll write it down. So we have 20,000 times 1.139279. Let's see, how far do they go on here? They go 9603. So they end up rounding it because if you look at my calculator again, it doesn't stop right there. They ended up rounding it right here. So they do end up rounding it. Go out quite a few decimal places. If we look at the chart here, you know, we want to at least go out 1, 2, 3, 4, 5, 6 decimal places. That's definitely important. We want to go out that far. They went out quite a bit farther than 6, but not a big deal there. So then we're going to take that amount and multiply by our 20,000. That will give us the first answer here. So once we actually do the multiplication, that's the answer here. The second answer is pretty darn simple. We're just going to take whatever we got for his future value. So after the 4-year or the 2.5-year period, how much does he have? We're going to subtract that from what he put in, the 20,000, and that'll tell us how much interest he made. All right. I hope that helped, and I will see you in section 2.